In the previous session, we were looking at the various options of plotting, and in a graph, how to add the X label, Y label, legends, etc. Also, we observed how to give the limits for X-axis values and the Y-axis values. In this particular session, let's first see, once we specify the X and Y limits of our plot, let us say how to give the specific X and Y values, right? It's called as XStick value. In the sense, every tick along X-axis you may want to plot like 1, 1.5, 2, 2.5, etc. But by default, it is not possible. MATLAB will not show that by default, right? How to change it is what we are going to see now. All right. So first, let me clear everything. We'll create a new set of variables. Okay, so let me create X and Y values first. So X is equal to, say, linear space between -10 to say +10, and I want this time say 200 values. All right, so X will be created with as per the specification. Then say Y is equal to cos of all these X values. Okay, Y is equal to cos X. All right, once that is plotted, now I go for a plot to show you what happens by default. X versus Y, I plot. Now you see the x-axis or the y-axis values are -10, -8, -6, -4. See, this is by default, right? I have not specified anything, right? I have not specified MATLAB saying that I want these values to be plotted, right? So you can see that in this graph, the 10, 8, etc. are the tick values. So we call whatever tick values are there along x-axis, we call it as x tick value. And whatever the tick values you have along y-axis, we call those values as the y tick values. So we can change, we can specify we can specify for a given graph that what I want to be plotted as the x tick value and a y tick value along with the graph. Okay, so now I'll show you how to do that. For the same graph, let me specify what tick value I want. So I will specify, say like this. You can specify where you want the tick values by using x tick. Okay, when I say x tick, it should be a plural. So sorry, x ticks. I will. It is a function, so I have to open a bracket. Then I have to specify the array indicating what all the values of x ticks you are expecting. Okay, so I'll open a square bracket and I specify my first one. I'm expecting say -3 times pi. This is actually an array, so you see it's not a character array, it's the normal array of real number. So -3 pi, right? -3 times pi will be uh, stored over here. Then I want -2 times pi. Then I want minus pi, then say 0, then I want pi, then I want 2 pi, then 3 into pi. Okay, these are the locations at which I want the x ticks to be plotted on my graph. Now just check whether there is any change on the graph. You can see that it changed now, right? So 0, minus pi, minus 2 pi, but you see it's not showing the pi as a symbol. It actually shows minus pi as -3.1416. But now I can definitely change and I can put the pi over there. You know how to bring the pi symbol over there, right? So to say what you want to be shown at those tick location, right? In order to show what you want to be printed at those x tick location, you are going to use another identifier called XStick label. So label suggests I want that label should be shown at that point in the x-axis. All right, so let's use the XStick label now. So this is how you are going to use. Okay, so I will write the required identifier called XStick labels. So that is XStick labels. I'll open this and then I specify. Now you see I'm specifying what I want to print over there as a character array. So when you write a characters in the form of array, it has to be cells by default. We know that in MATLAB. And I'm supposed to use the flower bracket. Okay, so let's use the flower bracket. What is the first number I want to print over there? First tick value is minus 3 pi. So I have to print a minus 3 pi, but the format is inside a single quote, type minus, then 3. I want to print a pi as a symbol, so backslash pi. This is the first, correct? First tick label. Then specify what you want in the next tick label. So this has to be minus 2 and the pi as a symbol. Okay, then I want to print simply pi. So it's minus pi, my mistake. So type in minus first, then this pi. All right, then I want to print out 0. It's a 0 anyway, by it's always a 0. So I have to specify 0 as a character array. So put a O, sorry, it's O. It's not O, it's a 0. All right, then I just want to print a pi. So this is pi. Then I want to go ahead with the 2 times pi, and the last tick value want to print is 3 times. Okay, close this and close it. Now you press enter. Just check what happens now. What is changed? You can see that the x-axis changed from minus 3 pi, minus 2 pi, pi, minus pi, 0 pi, etc. Correct? So exactly as per your requirement, you can change the XStick label. Now I can also specify, instead of you see that here we actually XStick labels, we calculated and gave a linear space. But is it required? Always should we give a linear space? So the answer is no. You can specify any location where you want to have a tick. Now I will show you that when we use the Y ticks. Right? Okay, so let's go to the Y ticks now. And so Y ticks, I want the Y ticks uh, to be uh, non-uniformly spaced. Okay, so I'll just use an array, maybe minus 0.8, then I want minus 0.2, then maybe minus 0.1, then 0, then maybe 0.1, maybe 0.5, maybe 0.9. Let's see what happens if I use like this. Okay, so it accepts, and you can see on the graph, right, it is actually plotting minus 0.8, minus 0.2, point this is it's not linearly spaced, not equal space among those tick values. You can use anything you want. All right, any specifications can be mentioned over here. According to that, the x and y ticks can be plotted on the graph. This is very useful function, very useful feature, right? There is nothing called as a default. Default will be the simplest plot, but later on, according to your requirement, definitely you can modify. Okay, so that's what is called as the tick values and the tick labels. Okay, in addition to that, the next option that we widely used when it comes to the plotting of the graphs is called as the grid lines, right? I have again a variety of options to plot grids, right? Grids helps the readability, grid helps in the improvisation of the readability of any graph, right? You get grids means you will be able to get more details or more accurate values on the graphs by just looking at the graph. So we want grids. So how to do that? We'll check that. So the concept here is called as the grid lines. So what are the grid option lines, how to bring the grid options and how to modify the grid spacing, etc. Is what we are going to see now. Okay, now first let me create a graph. So I will create say y is equal to, I don't want to create a x, let me directly go for y itself. All right, so this is a random numbers. I'll create the random numbers 10 comma 1. You see, right? We created 10 numbers of this, and I'll call a bar function. Right? We know what is a bar function, so I'll call bar of y. And you can see that a bar graph came into picture, right? And it looks like this. So at every position 1 to 10, you have various amplitudes, and each of the amplitude is marked by a bar. Now on this bar graph, my idea is that I want to bring the grids into picture. So how to turn on grids? It's very simple in MATLAB. You just have to call the grids as grid, and you simply turn it on. So as you press enter, you can see that the grids have been created, right? So all the grids come into picture, and you can see that by default it adjusts the size of grids, right? So that the details of the graph is clearly visible, right? So this is the first thing in MATLAB to bring the grids. Okay, for the default way is that the grid lines will appear at each and every tick mark that is present on the x-axis and the y-axis. Default is that, but right, later on we'll see how to modify. Right, so the first modification that I want to show you here is, right, what if I want more resolution in terms of the grids? So you can see that between 1 and 2, I don't have any further subdivision in terms of grids, correct? It's like wherever you have a tick, you get a grid, right? But you don't get a grid at any other position, right? Between 1 and 2, I want further subdivision in terms of grids. If you want, right? Is it possible? Yes, answer is true, it is possible. You just have to specify, after turning on the grid, mention that I want the grid to be, right? You see, I want further subdivision among the grids, right? So smaller grids, if you want, you can call it as minor, minor. Simply say minor. And when I press enter, you can observe the change, right? So between the previously had whatever grids we had at the initial stage, they were the default grids. You get subdivision of the grids, you will get minor grids as well. Okay, this increases the clarity of the graph. Okay, then let's say now if I turn on a grid, I should be able to turn it off as well. So yes, you can turn off a grid by using the command grid space off, right? Now let's see that. So simply call grid off. So as you can see on the graph, the grids are vanished. Right, so you can create a grid, you can go for a minor grid, and you can turn off grids if you don't want. So these are the options related to the grids and the formatting of the grids. Right, now let us say we create the graph, specifically a 3D graph, and let me say I want a different color in the 3D graph. So let me explain once I write something here. So let me come back to the notes part, and our next thing is about the changing the color scheme of a graph. Okay, so this is what is going to come next. Okay, so this is our next concept. Let me show you how to do this. So first, let's create a 3D. Okay, so let's first go back to MATLAB. Let me clear everything, and let me bring up a figure f equal to figure, and let me let me call a surface plot, and I want to plot the x. Let's see, right? You can see uh, a 3D graph came into picture. It's a surface plot, right? But you can see that its color by default is in the range. The dark blue color, uh, it's the lowest point on the curve, and as you move up along y-axis, it changes to say a green color, and the peak value is close to the yellow color. So that's the range of color which is given to this by default. Now let me assume that I want to change it. So that's what I told, changing the color scheme of a 3D graph. So in order to perform that, I have to use an option called as a color map. Okay, now you see there is a yellow color at the top, yellowish, right? Colors you can see over there. I can simply change that by using what is called as a color scheme, and the keyword for changing the color scheme is color map. All right, so this is how you use it. So I'll call it's the color map, COLORMAP, and followed by I have to specify what is the color map I expect. There are a lot of color maps available. One of them is winter, right? You see the change as soon as I press enter. The complete thing changed only between the lowest position being dark blue till the light green color. So the yellowish color vanished. Okay, at the same time I can bring the color map in a different way. So you can even bring the color map uh, by calling the color map in the following fashion. That is, color map can also be called by using the figure handle, right? Figure handle for this particular graph was f, and you specify f comma. I can simply specify uh, the what color map I want. Say hot. Hot is another question. Let me press enter. You can see that it all automatically changed to the hot, that is red, and the lowest position being red, and the topmost position being the right yellow color. So this is the color map for the keyword hot, right? So you can actually go to the help and find a color map as a help, and you'll see what are the options you have in MATLAB, what are the various color options you have. But my intention was just to show you how to change this. Okay, so using this particular technique, we can change the color map. All right, So we have another question under the same color map technique. Is it default? Why don't you? Can I change? That's my question, right? Can I change the color map by according to my requirement? Right? Is it something like there are some defined keywords like winter, hot, etc., right? Should I use only those, or I can change, right? So the answer is yes, we can change. I'm going to show you now how to change that, right, according to my need. I'll define some colors, and I'll make sure that my the graph is going to having a range of colors between those which I define. All right, so let's go to that. So let me define the colors as per my wish. So I'm going to define something by my colors equal to. So let me say I want to have three different colors in this particular what we call graph which we have already created. Right? Let me define the colors in the following way. Uh, I have to create a matrix basically. Right? So matrix means it has to be it has to be the square bracket followed by tell the colors in the RGB format. So this is 1 space 0 space 0 indicate this is red. Okay, I want to have a red color over there. Then I want to say have the yellow color specified 110, and I want to have the blue color. So this has to be 001, right? So RGB, every row, right? Whenever you mix R and G, you get a color. So that's what I use as a second color, and the third color like this. Okay, let's say this. My mistake, I think. This has to be a semicolon instead of this. All right, so now we check. Okay, my colors, right? That has been created. Now, simply call a color map and you tell I don't want any other color, but I want my colors. Right? So my so just observe the output now. So in this output, you see the three colors which I mentioned, right? Red, below some threshold, it defined the red. The thresholding will be performed automatically, and you can see that the medium range is yellow and the highest peak values are given the values corresponding to blue color. So like this, you can define the colors and you can use it over there. All right. Now, what color corresponds to what range? If you want to see, right, you can simply call another. You can use a keyword called. It's called as a color bar, right? And I press enter. You can make a note here, right, in your output. So on the rightmost side, you got a range corresponding to each of the color, right? If your output range, that is the third axis, possibly I think that is a Z axis. Actually, it varies from -10 to +10. In that range, if at all the output is between -2 to -6, it is plotting using a red color. Right. At the same time, -2 to maybe -2 to +3 something, right? Close to that. It's using the color yellow for that. The second color which is defined in my color. And my color says the third color to be used is blue color, and automatically it detects the threshold for the blue colors as from 5 till 8. Okay, so that range is defined automatically, right? It will decide automatically depending on the number of colors you use. If you increase the colors in my colors, definitely you will observe that there will be more partitions and more colors and more range for each of the colors uh, to be used in the color graph, and you can bring up the colors details, what color for what range, by using a keyword or the command simply called as color bar. Okay, so that's the use of color bar. All right. Now, let us see. We have a specific graph and I want to save this graph into any specific format, right? So all the standard formats of pictures are supported in MATLAB. How to save it, I will show you. Okay, so let me write what is our next topic. So the topic that we are going to discuss now is printing and saving the graphics. Okay, so if you have a plot with you and let us assume that you want to save it, right, in any specific standard format, right, so that you can copy it to some location and you can bring it into another computer and you can uh, open it over there. Okay, so if our intention is to do that, then this is what we can do. So let me bring up a plot now. I'll define x is equal to, let me define some values, 1, 5, 4, 7, 0, 6, 3, 2. Okay, so this is the x and I'll call bar x. So it brings up a bar. All right, so I got a list. Now, in order to have a printout, right, I can go to the file and select a printer, right? So go to a file and normal print, right? You can go to a print. And as you can see that when you go to the print option, right, we get the details like what to print, which printer. It's a normal printing option, how we print the normal files. Okay, so what is the option? To get a printout, hard copy directly, or to save it as a PDF format, you can go for the file option, which is over here. It opens up the file options, and in the option you can actually select, right, the printer option. Okay, that is present over here, okay, in file, right, that's actually present over here, the file options. You press on that and you will get that. That's the first option. And the next option that we have to print is that you can go to a print preview, right, in the file. You can go to a print preview, right, and save as a figure, right. You can simply select the color option. As soon as you select the print preview option, right, you will see that another print preview comes up and you can simply select the color as same as the what you call figure, right. When you click on the same as figure, even the background is retained, right. If there is a background, that gets retained, otherwise everything will be white. Okay, so that's the option to save this. Okay, I think the saving window was not visible to you. I'll just save it and show it on our notes. Just a second. So let's see, this is how it can be done. So when I opt for the size of the figure and the placement of the figure, where I want to place it, this is the option that I get on my window. I have taken the screenshot and I'll paste it over here. So this is the window that actually pops up. You can see that the print preview, and I have a color option, I have a layout option, etc. The same graph which I just plotted, right? The bar graph I can see over here, right? So using this particular bar graph, here I have the various options. So in addition to this, this is the other option that I'm going to get here when I select the line options. So what is the thickness of line if I want to specify? Yes, that can also be done here. Okay, so that can be done using the line options, and when you select the line option, you get something like this. You can see you have an option to say specify what should be the thickness of the lines, right? What should be the width of that, right? And also I can specify what is the text I want to save, right? Font, what is the weight of the font, what's the angle, etc. And if you want to copy the figure to clipboard, I have a figure and I want to copy that to a clipboard, right? Once you have it in a clipboard, you have a variety of options. You can paste it at variety of locations and do a lot of modifications in that. If you want to paste it onto the paint options and modify that, etc., can be done. So when I go for that, I'm getting this option, right? So I had the figure, go to the edit and select copy figure. So as soon as you click on the copy figure, that image what is present in the form of a figure gets copied into the clipboard. Directly you can paste it over Word file, you can paste it anywhere you want, right? So whatever document you are creating, whenever you want to copy the results of your project to your thesis, right? So this is the suggested way, so that you maintain the clarity of the image, right? So maintaining the clarity is also very important. So this actually saves the clarity of the image, right? That we have, right? Then again, I have another option to save the what you call plot using an interactive technique. Rather than going to the edit or the file options on the screen, I can actually use this. Okay, I'll just directly show it here. Instead of running the code, I'll show you. So let me say I have this plot with me. Okay, let me take a screenshot first. Okay, let me paste it. So now you see I'm having a screenshot like this, and when I click over here, right, I'm getting an option, three options, out of which the first option is the common save option. When you click over there, right, it opens up the saving window, right? So that actually opens up this window. Again, I'm taking the screenshot. So you can see that it actually goes into directly to the save as option. I know that using the save as option, I can go for, right, I can select, right, what is the format and what the particular, sorry, what's the file name and what is the specific format in which I want to save, right? Both comes up. You can select a PNG if you want, other TIF, PDF, PNG, etc. Anything you want, you can select here. Okay, now say if you want to save any graph in MATLAB's own format, right? That is also possible. Okay, so let me show you that now. So this is the save the figure and reopen the figure, like how I save a variable into a mat file or dat file, right? So that I can open it later when I come back, right? Same thing can be done even for the MATLAB figures. So these are the, I have to create a figure first, and I can show you how to save it into the file location, right? The default folder where I can save it, the current folder, and I can open it at any point later, right? So let's look at that now. Fine. So this can be done. So the next option that we are going to see now is saving a figure. To save and reopen MATLAB figures. So let me come back to the MATLAB and let me create the required file. Okay, there is a bar already. I think that's vanished. I'll just open the bar. Okay, so this came up now. Now, my intention is to save this. So I have to call the function by the name save fig. So when you call it as a save fig, it will save the figure itself, right? Whatever is the figure that is open, that figure will be saved, and you have to just mention what name you want to give, and extension is fixed here. I cannot change the extension. Let me say this is my bar graph. .fig is the only format that is supported as a MATLAB figure. This is, see, you are saving it as a MATLAB's default what you call format, right? You can save PNG, JPEG, etc., TIF using the other method which I mentioned earlier, right? So if you want that, you have to use it. But this is the easiest way to save and quickest way to reopen, right? If you want to use the MATLAB's own technique, then that is the default one and that's the easiest one, right? So anyway, since my intention is not to take a printout, I just want MATLAB to remember this and recall when I want. That's why I'm using this method. So just say press enter, you can see that the mygraph.fig comes in the current folder. So this is because MATLAB saves in .fig format by default and it gets saved in the current folder of MATLAB. So it is saved now. So what you can do here, I just want to show you how to open that when you come later, right? In order to do that, let me first close this figure. Let me say that this figure is not there. I don't have this figure. So how to do that? Either I can close it, but let me use a function that is GCF. It's get current figure, and sorry, it's not GCF. It's close of GCF. I have to say that current figure, you close it, right? So close, you write GCF, right? That's whatever is the current figure that is open, you close it. So as soon as I do that, it closes, right? So that is closed now. Right. And now my intention is to open that particular figure which I already have saved, right? So I have to call open fig and specify the name of the file which you had saved, right? So I think I have saved it by this name itself. I'll write my dot. So click it, it comes up. Right? So actually you are reading it directly from the saved location. It's not a plot, it's opening that. So you had closed it and you are opening that now directly from this. All right. Okay. So this brings up to the end of the graphics part. The whole concept of plotting uh, various types of graphs and making variations in the graphs, making changes in the parameters and annotation, right? Specifying what color you want, etc. We try to cover up in this particular session.